Alrighty, so here is our next bit of notes for Unit 5 in Algebra 1. So, there it is. So, as of right now, so we're Unit 5.3 and 5.4. That's kind of one unit that we kind of just stuck together. So basically, from what we've been doing in class and also on these notes is that we've been solving systems of linear equations, and we've been using, again, the two methods we've been using. We started off by graphing, and then we went on to substitution. I'm just going to put a little sub right there. And now we're solving systems by using elimination, right? And it basically is, it's exactly what it sounds like. We're going to eliminate one or multiple of the variables when solving the system out there. So here's the little kind of notes in your note packet. I'm not going to spend too much time on these. I'm more of, I'll kind of go over these, but like in an example. So if you want to pause the video right now, you can go ahead and write these down. But I am going to move on in 5, 4, 3, 2, 1. So here we go. So solving using elimination. So first of all, what you're wanting to do is you're wanting to, first of all, identify a variable that you can easily eliminate. And what do I mean by elimination? Well, basically what we're going to do is we're essentially going to take this equation up here and this equation up here, and we're basically going to add them. But we can even subtract them as well, but I'd recommend just adding them. And when we add them together, we want to have one of our variables just go away, cancel out, and we're left with, just one variable to solve for. So let's take a look here. And when we're adding our variables together, we want just, again, one of them to cancel out. Now let's take a look automatically, see if we have any variables that cancel out. 3 and 2, no. If I add those together, I'm just going to get 5x. And again, when we add these together, we just add them straight up. 3x plus 2x, we're just going to get 5x. Now we got the negative 5y and plus 5y. And hey, look at that. If I add those two together, I'm going to get, 0y, or they just cancel out. So that's the variable that I'm going to cancel out, is my y's, all right? So I cancel out I'm adding my equation together. I add my 3 and my 2 together. I get myself 5x. I add the negative 5y and the positive 5y to just get 0y or cancel them out. And then I bring down my equal sign, and then I also add together my negative 16 and my 31 there. So again, negative 16 plus 31, that just gets me positive 15, okay? And then from there, we should know how to solve for x here. 5x is equal to 15. Divide by 5 on both sides. We're going to get that x is equal to 3, okay? So again, and I'll kind of put my solution down here is 3. And again, we want both an x and a y value, just as we've been doing this whole time, solving systems of equations. So now, again, what I'm going to do, just as I did with and again, once I get to this part where I figure out either my x or my y value, it's basically the same process. I take my whatever x value I found and I plug it back in to one of my equations up here. Right? I could either plug it in for my first equation or my second equation. I always just say, pick the equation that looks easier for you to use and use that one. I'm going to use the second one right here. So I'm going to plug the 3 in for x. So it's going to turn into 2 times x is 3. So I'm going to do 2 times 3 plus 5y is equal to 31. Again, we're just trying to solve for y. So I add 2 times 3 is 6 plus 5y is equal to 31. I'm solving for y, so I need to get y by itself. I subtract the 6 on both sides, get 5y is equal to 25. Y is going to be equal to 5. I divide by 5 on both sides. Y is equal to 5. Oop. And that is our final answer right there, okay? So again, that's basically the elimination method. Now we'll go back to our methods again. You decide which variables you want to eliminate. You add the two new equations together, and then you plug your answer into any equations, okay? Basically the one we've been doing before. I'll kind of hit on this second example here, the second step here in just a second. That's kind of the optional, if needed, example. So let's take a look here, all right? Let's say, are there any x's or y's that if I add them together, they will cancel out. And it just so happens that once again, if I add my y's together, negative 3y plus 3y, I'm going to cancel those out. I'm going to cancel my y's out. So I'm going to cancel my y's out by adding my equations. So I'm just going to add my x's, 2x plus x, that gets me 3x. Negative 3y plus 3y, those cancel out, so those just go away. And then negative 11 plus 8, that's going to give me a negative 3. And then I'm going to solve for x, obviously. X is going to be equal to a negative 1. So I'm going to put my final answer down here. X is equal to negative 1. Now we need to take our x and plug it back into any of the equations. We could plug it in for this first equation, but the second equation looks a little bit easier to work with, so I'm recommend doing that, so I'm just going to plug it in for that one. So I'm going to do x, which again I'm going to plug in a negative 1, plus 3y is equal to 8. Let's see, this is a negative 1, so I have to add it to both sides in order to solve it. So we get 3y is equal to 9. I'm going to divide by 3 on both sides to get y is equal to 3. And that is our final answer right there, okay? Alrighty, so, and it looks a little bit crooked over here, but that's okay. So now let's work with an example that isn't really clear right off the bat. So if we look over here, you know, we want to see, are there any x's or are there any y's that if I add them top and bottom together, I will cancel them out. But if I look, well, 3x minus x is 2x, and negative 2y plus y is negative y, so none of them really cancel out. So now what I need to do is I need to basically manipulate one of these equations in order to where I can add them together to cancel out. And this is where I'm going to kind of cancel back. This is where this multiply one or both of the equation steps come in. We're going to multiply one of our equations in order for us to cancel out our variables. And what I always want to look for when I'm multiplying my equations is look for, you know, as I kind of said earlier, look for a singular x or a singular y, all right? Because in this example right here, say if I were to multiply, you know, say by 3, this second equation by 3, I'm going to bring this first equation down. It doesn't change at all. Minus 2y is equal to 9. If I multiply this first equation out, I multiply the 3 to all of the terms, not just on one side of the equal sign, but to every single term. I get negative 3x plus 3y is equal to 3. And if I look at that, hey, my x's can be canceled out now. Now, if you also were like, hey, I wanted to simplify the y's out and multiply by 2, you could do that as well. But I'm going to just stick with just the x's for right now. So once I multiply out my equations, now, as I've done before, now I'm going to add them together. I add the 3 x's together, they're going to cancel out, all right? I get negative 2y plus 3y, that's going to give me a positive y. And if I do 9 plus 3, well, that's just going to give me 12. And hey, look at that, I get y is equal to 12. So that's the first part of that's the y part of my answer there. I'm going to take that y is equal to 12. We can plug it back into any of the equations we want to. Again, I just recommend use the equation that looks easier for you. I'm going to say let's use this second equation here. So I'm going to plug in a 12 for y. So it's going to be negative x plus 12 plus y, which is 12, and is equal to 1. I'm going to subtract the 12 on both sides to solve for x. You got negative x is equal to a negative 11. Divide by negative 1 on both sides to get rid of that negative. We're going to get x is equal to 11. And that is our answer right there. Okay? All right, so again, that's kind of the elimination there where it's not that obvious. Now let's take a look at another one here. So we got 2x plus 5y is equal to 3, and then we have 3x plus 10y is equal to negative 3. Now, we want to look for, you know, a variable to where I can easily manipulate it to cancel out, just like I did. I want to find an equation that I could multiply to where it matches up or it can cancel out with one of the variables on the bottom. Now, you can pick any variable you want, but I would recommend is that once you kind of get in the hang of this, you're going to see that, one variable is going to be a lot less work than the other variable. And if we're using our multiplication method, it looks like, hey, all I need to do is multiply this first one by 2 in order to match up my y's, or in order for my y's to cancel out. But let's actually look at this. If I multiply by 2, I'm going to get 4x plus 10y is equal to 6. Well, if I just go ahead and add my y's together, I'm going to get a 20y. So what I have to do is, instead of multiplying by positive 2, I multiply by negative 2, and I negate all the numbers inside there. Oh, went a little bit too far. So now, if you wanted to stick with, just multiplying by the 2 and subtract, you can. I would recommend, if this were to happen, just multiply by the negative number, all right? That's, it's a lot. It's, if we're subtracting, I don't like subtracting by negative numbers. It just, we don't keep track of our negative numbers well enough for me to feel comfortable with that. So if we get into this situation to where, hey, I have the same numbers, but, they're both positive, multiply one of the equations by a negative number, and you'll be fine. So now I'm going to add the 3 and x on the 4x. I'm going to get a negative x. I add the 10 y's together. I'm going to get, those are going to cancel out, and then I'm going to add the negative 3 and the negative 6 to get myself a negative 9. And just as I did over here, I'm going to divide by negative 1 to get x is equal to 9. Okay, I'm going to write these over here. I'm going to get x is equal to 9. And now we can take this, plug it into any of our equations. We don't have to plug it into both. We can just plug it into one. I'm going to plug it into this first equation up here. So it's going to be 2 times x, which is 2 times 9, plus 5y is equal to 3. 2 times 9 is equal to 18, plus a 5y is equal to 3. I'm going to subtract the 18 on both sides. I'm going to get 5y is equal to a negative 15. I divide by 5 on both sides to get y is equal to negative 3. And that right there is our final solution to our system right there. Okay, so now, and going a little bit too far there. So now we need to solve the system by using elimination. But now it's not going to be as, straightforward as to which numbers or which equations I need to multiply. In fact, for these examples, we might need to multiply both our equations by a number, okay? Now, let's just pick, a number to, let's just pick a variable. Let's just pick x for this one, okay? Because x, it's a negative and a positive, so it's going to be easier to manipulate. So I want to multiply the top equation and the bottom equation by a number, so where I basically have a positive version of an x and the negative version of that same x. And if we look, well, shoot, if I just multiply 4 and 3, if I multiply this top one by 3 and multiply this bottom one by 4, they're both going to give me 12. So let's go ahead, and that's the number that I can multiply both these by. So let's go ahead, we're going to multiply, we're going to pick the x's to simplify. I'm going to multiply this top equation. Actually, I'm going to erase some real quick here. Actually, I'm going to erase. And I'm going to multiply this top equation by 3, okay? I'm going to multiply, distribute all of them out. We get ourselves 12x plus 15y is equal to 70, going to be 105. Now, I need to multiply this bottom equation by a number because it doesn't look like any of our numbers really cancel out, so to speak, so far. But I see that if I multiply this bottom equation by a 4, I can distribute this 4 out to get a negative 12x plus 8y is equal to a negative 36. And then look at there, my x's now simplify out if I add the equations together. So let's go ahead and do that. I add those together, the x's are going to cancel out. I add the 15 plus the 8, I am going to get 22y, and then I'm going to do 105 minus 36. I'm going to do that on a calculator here real quick. 105 minus 36, that's going to get me a 69 right there. I'm going to divide by 22, and it doesn't look like I get a, hang on, let me double check real quick. I get a 23 for this y, excuse me. Sorry for the flub up there. 15 plus 8 is equal to 23. You get 23y is equal to 69. We get y is equal to 3. I'm going to take this y, plug it back into, let's say, this second equation here. and it's going to get negative 3x plus 2 times 3 is equal to 9. I'm going to